Hi, good day everyone. So let's continue our discussion on the second law of thermodynamics. So we have this in internal combustion engine. Say there are two types of engine. We have gasoline engine and diesel engine. So in the gasoline engine, there are basically four strokes na mahitabo sa imong gasoline engine. Sa diesel engine po, four stroke lang yapon but nasa somewhat difference uh, sa imong gasoline o sa diesel engine. I will discuss that later. But basically, there are four-stroke engine. We have first is intake, second is compression, third one is power or called combustion stroke, and the last one is exhaust stroke. So in intake stroke, a mixture of fuel and air. So ang fuel nga is gasoline enters into a cylinder through an open intake valve while the piston descends. So, dari, sa intake stroke, musulod imuhang air o imuhang fuel dira, and then while the piston kay mo while you increase the volume of this one, and then after that ang intake valve, which is this one, pag close ang nakaroon, the intake valve closes and the mixture is compressed. I-compress siya, gamay ang volume, and then this stroke, we call this one as compression stroke. Intake valve closes, mixture is compressed as piston moves up. And then after that, you decrease the volume, and then after that, the mixture is then ignited by the spark plug. So, muna ang naka-differensya sa gasoline o sa diesel engine. Ang gasoline engine kay ni gamit og spark plug for ignition. So, na ignition na itabo dira. Okay? Ang spark plug mo ma-ignite sa imong engine. Okay? The mixture is then ignited by the spark plug, and the heated gas, what will happen to this? Na-compress mo siya, no? The heated gas expand. So that is why the increase of volume, the heated gas expand, pushing the pistons down and doing some work. So at this point, the piston is doing some work. We call this one as power stroke, or sometimes we call this stroke as combustion stroke. Okay? So dire dapit na ang nagdo work imong system. Okay? Sa power stroke. Okay? And then the last one, the exhaust valve opens and the combustion products are pushed out during the exhaust stroke. So diri mo gawas na karon ang itong mga wasted products or wasted heat, leaving the cylinder ready for the next intake stroke. So take note, this is a cyclic process. So intake, compress niya, ignite niya using spark plug for gasoline, for diesel kay walay spark plug na gamiton. And next one is pag ignite, there is power stroke, and then after that exhaust, then balik na po ka sa intake stroke. So natay upat, no? Intake, mosulod imong gasoline, imong fuel, compress imong gamay yung volume, and then ignite, there's an ignition, there's a power stroke, and then the last one is exhaust stroke. So muna yung mahitabo basically sa ato ang sa ato ang internal combustion engine. So mura sa ingani, no? Na po 1 2 3 4 ka stroke like that. Exhaust, intake, compress, power, and then exhaust. So that's the 4-stroke engine. So load, compress, then power, pag-ignite ani. Okay, pag-ignite na then exhaust. So that would be the 4-stroke engine. So para makita kayo ninyo, maklaro kayo ninyo ang unsay sulod sa inyong engine, please watch this video sa YouTube na lang. So i-post lang nako or i-append ako ni siya o post sa ato ang group chat. Pero talang to, no? Kanilang dito dapit. Kita nimo ang upat ka klase.
Hey, it's me, Destin.
Stroke. Sorry.
Okay, now that you know how an engine works, watch each of the 4 strokes and see if you can identify each one. Intake, compression, power, exhaust. Intake, compression, power, exhaust. Now think about the engine in your car. All the explosions are synchronized together to make that one constant engine roaring sound.
So na dito makita ang upat ka stroke, intake, compression, power, and exhaust. Okay, so as you notice here, sa heat engine, sa itong basic na definition sa heat engine, you are just converting heat, absorbed heat into work. So kung lang taon mo ani, this is an example of a heat engine na nag-absorb ng heat direct. Okay, gikan sa intake kani, this is absorb heat and then doing some work, but take note dili tanan mo convert into work. That is why nako exhaust nga stroke dira. So muna ang basic na definition sa heat engine, converting the heat here into mechanical work, and then since uh, we cannot convert it completely to mechanical work, then there is this exhaust rejected na heat sa imuhang sa ikaapat na stroke, which is the exhaust stroke. Okay, so that is heat engine. Okay, so as I said, there are two types of heat engine. Ako gasoline engine and then ako diesel engine. So ang kalayan sa duha is basically katong ang pag-ignite sa imong na ignition nga mahitabo. Sa gasoline, ang gamit nila for ignition is spark plug, while diesel kay dili na siya kinahanglan og spark plug na para mo-ignite. So naay gitawag na self-ignition sa diesel, na once dako kay mong temperature, then mo self-ignite lang siya. So, na self-ignition na may kabo because of the increase of temperature. So more na actually ang kalahian. Nagyapon sa upat ka stroke sa gasoline ug sa diesel, same lang yang upat ka stroke na intake, compression, power, and exhaust. Ang kalahian lang niya is dito dapit sa power stroke, wherein ang gigamit sa gasoline na ignition is katong spark plug, while ang diesel kay dili na siya mogamit og spark plug. No, self-ignite lang siya because sa katong na-process din to ma-increase niya ang temperature sulod sa imong piston. Okay? So this is basically the gasoline engine and diesel engine nga process. Lahi siya process. Take note in the PV diagram kung tawon nimo, lahi ang process sa gasoline engine ug sa diesel engine. Kung tawon nimo, lahi ang iyang process, lahi ang form sa iyang process. Sa gasoline engine, we have this Otto cycle. Otto cycle is an idealized model of the thermodynamic process in a gasoline engine, while kani is we call this one as diesel cycle. Okay? We call this one as diesel cycle. So unsay nahitabo sa gasoline ug sa diesel engine? Unsay kalayan sa duha, no? Okay, so let's start with gasoline engine. So muna ang process sa gasoline engine, natay duha ka adiabatic process. Mag-start ta sa point A. At point A, the gasoline air mixture has entered the cylinder. So nadra ang intake na stroke, and then the mixture is compressed up adiabatically to point B and is then ignited. Okay, so at this kaning arrow, ang yung process is adiabatic, nadiri ang compression stroke, and then pag ignite mo sa spark plug, heat now is added to the system. So at line BC, heat kay ni-enter siya sa system by burning of gasoline along line BC. Okay? Then after that, the power stroke is the adiabatic expansion to D. Since pag enter nimo sa heat, nadira ang pag enter nimo sa heat, i-expand ang imong volume, then there is an adiabatic expansion from point C to point D. So diri mahitabo ang power stroke, and then the gas is cooled to the temperature of the outside air along line DA, hence mo reject siya og heat nadira ang exhaust na stroke. Okay? So nadira ang exhaust na stroke. So makita nimo upat ka stroke ra. First, sulod ang air o gasoline nga mixture, compress nimo using adiabatic na process, and then it enters ni enter ang system, constant volume, so unsa na siya, heat is added to the system, and then we have the power stroke, expanding the volume using adiabatic expansion. We call that one as power stroke here, and then the last one is exhaust. Gawas ang imong heat. So mo na imong gasoline engine. Converting heat into work, but there is this QC na waste na heat. Okay, so that is for gasoline engine. For diesel engine, start gyapon sa A, nagyapon dira sa ang intake nga stroke, air is compressed adiabatically to point B, same lang, no? Air is compressed adiabatically to point B, heated at constant pressure. Okay, so lahi nga process there, no? At constant pressure. Expanded now adiabatically to point D, so nadiri ang power stroke. Heat enters the system here, but take note, the fuel ignition heating at constant pressure. This is called as fuel combustion. This is a significant difference between the diesel and the gasoline engine or the Otto cycle. No? So because there is no fuel in the cylinder during most of the compression stroke, pre-ignition cannot occur, and the compression ratio R can be much higher than for a gasoline engine. Thus, this improves efficiency and ensures reliable ignition when the fuel is injected because of the high temperature reached during the adiabatic compression. So, muna yung kalahian, no? Lahi nga process ang gigamit sa gasoline o sa diesel engine. Kung ang taon nimo sa gasoline engine, nagamit siya og duha ka adiabatic process. Okay? Adiabatic compression and adiabatic expansion. Same sa diesel gyapon na siya adiabatic compression and adiabatic expansion from A to B and C to D. Ang nakalayan is kaning sa B to C and D to A. Take note, ang gigamit nga process dire is constant volume nga process, so gamit dire is isochoric process here, and then sa DA is also isochoric process, while sa diesel engine ang gigamit nga process from B to C is isobaric, constant pressure. So isobaric process here, and here is isochoric process. So sa gasoline, duha ka adiabatic process ug duha ka isochoric process, while sa diesel nakoy duha ka adiabatic process, nakoy isa ka isobaric, and then nakoy isa ka isochoric process. So lahi nga process basically ang sa gasoline sa diesel nga engine. Okay? Same nga pila ka stroke, upat ka stroke, ang process nga gamit is lahi, and then ang katong ignition lahi sila o gamit sa katong fuel ignition. Okay? Gasoline is they use spark plug, while diesel kay nagamit sila tong high temperature nga self-ignite na siya. Okay, so that's gasoline and diesel engine. So let's now go to refrigerators. A refrigerator takes heat. Take note, bali ang process sa heat engine. Takes heat from a cold place inside the refrigerator and gives it off to a warmer place, which is the room. An input of mechanical work now is required to do this. So basically, a refrigerator is a heat engine operating in reverse. So ang arrow, ang tawag mo, ikan siya sa cold reservoir, and then padulong siya sa hot reservoir, pero dili nimo ni siya mabuhat kung walay i-input nimo nga mechanical work. Take note, modify sa second law of thermodynamics ang kaning the direction is from colder to hotter region. That is why kinahanglan ka og work, input work para mabuhat nimo ni siya. So we call this one as refrigerator. Okay, so these are basically the two devices. We have heat engine and refrigerator. So notice Ang tanin mo ang energy flow diagram, heat engine and refrigerator. Bali, ang refrigerator sa heat engine. Okay? So, ang heat engine is convert mo ang heat na absorb into work and then nasa yung waste na heat QC. So, refrigerator, it is impossible na ang heat flow is gikan sa temperature na gamay, okay, sa cold region padulong sa sa hot region. So it's impossible. That is why you need to have some work outside. Kinahanglan ka magkuha og work outside para mabuhat nimo ni nga device. Okay. So this work here is coming from a source say for refrigerator kaya ang dadung sa work is ang compressor. Okay, so ang dadung sa work is ang compressor. Again, if there is no work here, kung wala yung work nga mosulod sa imong system, then kani nga arrow kay impossible siya nga mahitabo. It defies the second law of thermodynamics. Okay, so that's refrigerator and heat engine. From economic point of view, the best refrigeration cycle is one that removes the greatest amount of heat from the inside of the refrigerator for the least expenditure of mechanical work. The relevant ratio is we call this one as coefficient of performance denoted by K, which is equal to the ratio of the QC and the work input of refrigerator. Okay, so K, the coefficient performance now is equal to this one, QC over QH minus QC. Okay, so the principles of the common refrigeration cycle are shown schematically here. So for number one, we have compressor. The compressor kani, so si compressor mo'y magdo sa work tungod anin niya may tabuang o mabuhat nimo ang refrigerator device. Okay? So mo na ang key point sa imong refrigerator. Kung wala ni, then wala yung refrigerator na mahimo. Okay? So ang compressor mo'y magdo sa work. Okay? Mo na katong sa diagram kaning W dari mo na ang imong compressor sa imong refrigerator. Okay? So kinahanglan siya para makahimo ka og refrigerator ng device. Okay? So the compressor takes in refrigerant fluid, okay, and does work on fluid to compress it adiabatically in the direction and it delivers to the condenser coil. The direction is going here. The temperature is much greater than the temperature from the outside. Okay, and then the compressed fluid in condenser is at higher temperature than the outside air. So fluid gives off heat to air, and then fluid partially condenses to liquid. So condense siya to liquid since the gives off na siya heat. And then the fluid, so natin itawag ng expansion valve here at this point. The fluid now here at this point expands adiabatically through this expansion valve. And then once mo expand siya, the fluid expands, it cools off considerably. After expansion, fluid in evaporator is now at lower temperature. Since the fluid expands adiabatically, it cools considerably enough that the fluid in the evaporator coil is colder than its surroundings. So therefore, this fluid absorbs heat, QC, coolings contents of refrigerator. Then fluid partially evaporates to vapor. So metabo cycle lang din na compressor na po, and so on and so forth. So that is the principle of mechanical refrigeration cycle.